Hello and welcome to my probability distribution table project, or PBL, by Mohammad Zoubi and Wahab Mohammad. Now you're probably wondering, what is this probability distribution table and how does it work? What we do with this probability distribution table and how it works is we would drop a ball through the V-shaped funnel formed by the pins, and then we would determine the probability of certain spaces filling up. This demonstrator table utilizes Pascal's triangle, a standard distribution curve, and probability in an attempt for a hands-on experience and understanding. We also got it with a kit, so it came with the demonstrator itself, the pegs, 100 of them, and 100 polypropylene balls, as well as the instructions. An experience my partner and I share is when we had initially received the box itself, including all the items such as the beads and whatnot, and we remember simply assessing the information based upon what we see and not taking into account the probability at all. And we come to learn the next class that we had been doing it incorrectly, so we had to stay after school in order to understand properly what it was we were doing wrong and what we could fix. And now for the history behind probability. The first recorded evidence of probability theory can be found as early as 1550 in the work of Cardon. In 1550, Cardon wrote a manuscript in which he addressed the probability of certain outcomes in rolls of dice, the problem of points, and presented a crude definition of probability. The onset of probability as a useful science is primarily attributed to Blaise Pascal and Pierre de Fermat. While contemplating a gambling problem posed by Chevalier de Mere in 1654, Blaise Pascal and Pierre de Fermat laid the fundamental groundwork of probability theory and are thereby accredited the fathers of probability. The question posed was pertaining to the number of turns required to ensure obtaining 6 in the roll of 2 dice. The correspondence between Pascal and Fermat concerning this and the problem of points led to the beginning of new concepts of probability and expectation. Then comes our test results. We decided to test the most probable outcome in 2 different ways. The first being without letting the balls touch the funnel, and the second being while letting them touch the funnel. So, we have the results for without touching it as such from left to right: 0, 1, 3, 9, 12, 6, 3, 2, 1. You can see a sort of pyramid going on. It's not a perfect pyramid, but it seems to be more stable than the one where we allow it to touch the funnel. And the middle had filled up the fastest, so we did not have to use as many balls as the one where we did allow it to touch. Then we have the one where we do allow it to touch, and the results are as such from left to right: 0, 2, 9, 7, 12, 7, 6, 1, 0. You can see that there's more fluctuation around the middle. We had to use more balls because we couldn't get the middle to fill up or any other column to fill up as fast as we had in the one where we did not allow the ball to touch the funnel. And a similarity between these two is the fact that the middle had filled up first. And a big contrast is the shapes sort of formed and the amount of balls required. So it seems that if you allow the ball to touch the funnel, then it creates a higher amount of distribution and a new set of probability, whereas if you do not allow it to, there's a smaller amount of distribution and a lower set of probability. This has been Mohammad Zoubi with Probability Distribution PBL. Thank you for watching.